Today's guest is Ram, head of applied AI at Macrorize. Macrorize is an AI company rebuilding the foundations of healthcare with the aim of making the delivery of care predictive everywhere. Ram is also an educator teaching courses in person at Northeastern University Seattle branch and also remotely streaming to students on Springboard. In the past, when Ram was with Fred Hutch Cancer Research Center, he hosted my Python group, Puppy. Ram gave probably one of my top three favorite puppy talks of all time. The audience gasped when Ram shared how often radiologists misdiagnose lung cancer, and often the only way we know if a practitioner got it wrong is if the patient dies because of mistreatment.
Welcome, Ram. It's so amazing to have you on our podcast and going through your titles, everything from head of applied AI for macro eyes to senior data scientist, cancer research, all the way to visiting scientist back in the day. You've done some amazing work, and it sounds like you continue to do amazing work at macro eyes, as well as you have your eyes very much on the world of AI, not just in the developed countries, but also developing countries. And you're very liberal about educating people in Seattle and participating in
Mhm.
Puppy. Out of all of that you have going on, what are the top two or three things that you drive the most passion from?
Thanks so much, Don and Brian, for that very generous introduction. And I was afraid that you would ask a question like this, the top one or two things. The thing that I'm really, really passionate about is education for sure. And what comes a close second is trying to apply artificial intelligence to making an impact on places like Africa. So because they are, so close, I mean, there's no real first and second place there. What I do is try to bridge both in the sense that I take some of the things that I learn on the job and put that into my courses so that, students who are actually taking my courses can actually, benefit from this on the job training tips and tricks for handling real life data. And on the other side, if you're kind of teaching, you want to be on top of the game, and you always kind of learn about the new developments in the field, read the most recent AI papers. So that also sometimes spills over and trickles down to what I actually do at MacroEyes. So it's a two-way kind of a bridge.
Speaking about bridges, Ram,
Mhm.
I think you bring a very unique perspective that a lot of Americans miss, right? You attended school in Kerala, which is a very special place with very interesting statistics about what it's like to live there. And then, from my perception, I know a lot of puppy members just really don't care about Asia. And then I can't imagine there's many Americans who know too much about Africa.
Yep.
Um, do you get a chance to influence your students and giving them a different perspective?
Yeah, a couple of things there actually. So I mean, straight off, a lot of my students actually, no, I won't say most of my students at Northeastern come from Asia because it ranks high as far as diversity is concerned. So I definitely, hear about what problems exist out there in Asia. For example, one of my students from my last offering of the data science course here in Seattle did a project which predicted what's the best time to visit Beijing if you are really scared of breathing in highly polluted air. So that was really good. And on the other side, I mean, one of the reasons why I actually ended up in data science is actually because I lived in Kerala. Because Kerala is, as some of the different parts in India, believes very strongly in astrology. Right? So it's about predicting the future. So when I was growing up there, I mean, my aunts and sometimes even my mom used to come and tell me that, hey, I mean, there is this astrologer who predicts that, when you grow up, you are going to become a medical practitioner. And some of these things did come true. So I was wondering, oh my God, how do they actually predict the future? Or what magic do they actually do? But, when I was actually doing my PhD, suddenly it clicked. there is this thing called Texas sharpshooter logical fallacy, or cherry picking in plain English. So they were actually using cherry picking, and I was drawing all the circles around that. So what is actually cherry picking? So if you want to become a very good sharpshooter, and if you want to show others that you are a great sharpshooter, what you can do is you can get up early in the morning and go practice. And after a few months you will become a great sharpshooter, and most of your shots will actually hit the dartboard, and some of them might actually hit the bullseye. But my favorite way of doing this is actually not to get up early in the morning. Instead, what I do is I take this blank piece of wood, just fire a few shots, and kind of draw the circles around those shots. So, and then you can tell others that, hey, I mean, almost all of my shots have actually landed at the center of the bullseye. So, of course, this is a very bad practice, right? I mean, firing the shots first and then drawing the circles around it. So this is what I mean by the Texas sharpshooter logical fallacy. So the astrologer or the crystal gazers here in the US, they fire the shots. I mean, they make these predictions, and we actually try to fit whatever has happened in our lives around those shots. So we draw the circles. So we are actually falling prey to this logical fallacy. So then I kind of wanted to know if there's a real way, using data and science where you can actually make predictions into the future. So if you actually look at data science, most data science projects are about predicting the future. You're either worried about predicting how much of groceries are going to sell at Whole Foods, or if you work for Amazon, how much revenue are you going to generate? Which products are going to sell best? So living in Kerala actually has had a subtle influence on me actually getting into data science. In fact, my PhD was from a cancer center in India, and I actually did a small data science project way back in 2009, a predictive project. So yeah, I mean, being in Kerala has had major implications for my career in many ways, actually.
That is fantastic. And I looked up online while you were speaking, and the University of Kerala's motto is wisdom manifests itself into action. And I love that. And it sounds like you've definitely taken action in many fronts on educating people on predicting the future. But I always ask myself, and Don and I go back and forth on this as well, is how well do people really understand machine learning and data science? And how even those in the field, sometimes when I talk to them about things like precision and recall, that some of it goes past them. AI has a huge amount of hype. Our first couple episodes are already getting a lot of attraction. What is your feeling on the hype versus the reality of it, and the population understanding things like the base statistics behind AI and machine learning?
Fantastic question, Brian. So, I mean, it's kind of challenging to answer this because it really depends on the people that you talk to as to how much they understand, machine learning and what it can do, and more importantly, what it cannot do. So, it's definitely very, very powerful, and right now it's a powerful tool that can be applied in many, many different areas. The way I see it is this. I mean, you people get this idea after listening to professors talk about machine learning and deep learning, that you will need to understand an enormous amount of math to actually get to know or do machine and deep learning. So deep learning and machine learning are, deep learning is the kind of machine learning algorithm. It's becoming more popular. So the truth is that if you want to be a decent user and and a person who can understand machine learning techniques and data science, you don't need that much amount of math. I keep telling people. So when I actually teach the course at Northeastern University at the beginners level, which is still graduate level, the dare that I give them is, if you can understand, or if you know how to add numbers together, how to multiply them, how to divide and subtract them, and you understand logarithms, then I can teach you machine learning. And I have been receiving 5-star reviews at Northeastern University for the past 3 semesters, which means that this is possible. This is not rocket science at all. If I talk like this, the problem is that people think that we are underselling deep learning and machine learning. Well, the challenge actually is not in understanding the concepts, but actually in putting these concepts into production or into an application. So that's where the real challenge is, which means that all your understanding of the concepts of data science will have to meet engineering at some point. And that sometimes becomes an enormously challenging task. So that's where the challenge is. And I increasingly, have come to believe that, humans and machines, man and machine, as I like to call them, we are good in different things. So, humans are really good in different things, and machines are good at some other things. So we don't actually need to kind of think about machines replacing humans, or humans replacing machines and that kind of stuff. So it's more about how we can work together. So at the moment, it looks like if we can put the human in the loop, what they call human in the loop machine learning, we actually make much more progress rather than trying to build algorithms that completely replace human beings.
When you're bringing up human in the loop, that conjures up for me the word
Yep.
culture. And your career has straddled biology and healthcare and software, which there's a lot of cultural translation that's probably going on for
Mm-hmm.
you in terms of explaining different stakeholders what's possible and what you should do.
Yep. That is so true. So you have to speak different languages to different people. And so something that I did during my, college days is I used to appear on local television in different capacities. And I, love to kind of be part of shows and, sometimes teach on TV. And I've been on national television in India, and I have spoken on All India Radio, which is the national radio station in India. So all that has actually helped me to actually tell stories to people. So as always a storyteller, that's what I do best, telling stories. It can either be stories written in English, because I also write children's literature, as my hobby, but I also love to tell stories with data. So what you said makes a lot of sense, because if you go on talking about things like accuracy, precision, and deep learning to a person who's completely new to this field, he'll be left in the dark, right? So you will have to kind of translate all that stuff into the language that that person is used to. So try to put yourself into that person's shoes and see what he would like to hear, and whatever the truth is, and then try to communicate. So that has been it's a continuing effort, actually. So I mean, I will not say that I have perfected that art, still learning as we go along, but I love doing that. But where there's the machine learning person present, you can talk about, you can bring in all these technical terms like area under the curve and the ROC, so that communication becomes easy. So that is a challenge, and that is, I think, the if you are a data scientist, and if you really want to climb the ladder and go up there, you definitely would want to learn how to communicate to different stakeholders, and use different terms, learn the language of how to speak to a layperson, and also learn the language on how to speak to an expert. The same has been true for biology too, actually. So because I think I do a better job at teaching computer science and math and machine learning to people who don't know that, is because I come from a biotechnology background. So I kind of tell them how I learned the concepts. A person with no math background, how did I learn these concepts? So it becomes easy for me to communicate that excitement and some of the hacks and tips and tricks that I use to learn all this stuff, and communication becomes easy. That's my best response.
And that's a wonderful response. And it's wonderful to see your journey from being on a national TV to India to academia, of course. And now you've landed right smack in the middle of kind of life sciences, wellness, healthcare, whatever you want to label it,
Mhm.
with macro eyes. And I think it'd be interesting to everyone to hear a little bit about what you have going on right now on that front, and also just your general impression of how machine learning is playing well or not playing well with life sciences and healthcare.
Great question, Brian. So I just checked. I was kind of sure that you would ask this question, Don and Brian. So I just Googled for this, and it looks like there are 5. So I'm actually going to answer your questions in the reverse order. So how has machine learning and deep learning actually affected healthcare? There are at least 5 FDA approved medical products that actually use machine learning in the US. So we are already there. And a lot of these products that have been approved for use in the clinic actually do not replace the radiologist or do not replace the doctor. Right now, it's actually a tool for them. It's just like the stethoscope for doctors. So this provides an additional, very powerful tool. Well, sometime, some years down the lane, this definitely will lead to job displacement. I mean, a place where you needed 10 radiologists, you're only going to need like 8 or maybe just 7 radiologists. And a place where you needed, 10 pathologists, you are only going to need like 6 or 7 pathologists. But this is a great boon, as you can see, to developing countries and low and middle income countries where they don't have enough people to actually enough doctors and enough radiologists to actually see all the patients. So that is one part of my answer. And can you remind me on what the first part of that question was, so that I can get back
I
to
mean,
it?
particularly to macro eyes, kind of what's
Yes.
going on with macro eyes.
Yeah. Thank you for bringing me back. So what is MacroEyes? Well, MacroEyes, we are basically looking to impact healthcare and improve people's lives and also save people's lives. And we are taking a two-pronged kind of a strategy. So we definitely are interested in problems that are so unique to developed nations like in the US. And at the same time, we believe in diversity in all senses of the word and all meanings of the word. So we are also trying to use AI to make sure that we can impact lives, better lives in places like Africa. So let me go into details about a couple of these projects. So in the U.S., the project that we are really excited about is a project called Sybil. So Sybil is also a product. So what Sybil does is, if you make an appointment to see your physician a month out, our product Sybil can actually tell you if you are going to make the appointment or are you going to cancel that appointment. So this has enormous implications, right? I mean, because if you are a patient who's likely to not show up for that appointment, then that slot can be double or triple booked. Okay, you can pair that slot with a patient who has a high likelihood of showing up so that the doctor gets to see at least one patient. And we also optimize this problem so that based on your previous no show history, we also optimize your appointment, because the algorithm might actually find out that if you book an appointment on Wednesdays, you are never going to show up. But if you book an appointment on Thursdays, you are way more likely to show up for some reason. So if when you go to that algorithm to actually make an appointment, it will make sure that you get an appointment that is on a Thursday to maximize your chances of showing up. So that is the kind of work that we are actually doing in the US, because in the US, patient scheduling is a big deal. So in many places, what's actually happening is this. People who really, really need treatment, really need to see a doctor, cannot actually find an appointment for the next 2 months, especially for specialty care. Like if you want to see a specialist like a neurologist, you have to wait 2 months. And after 2 months, your condition might change for the worse usually. And that beats the purpose of you making the appointment at all. But the funny thing is that during those 2 months, a lot of the appointments are going to get canceled by the patients themselves. So wouldn't it be great if you can kind of, predict which people are actually not going to show up and give this person who really, really needs an appointment and book him into, the earliest available slot. So that is kind of the work that we do inside the United States of America. And let's shift gears and look at the stuff that we are, doing in Africa. So in Africa, one of the problems that people face is there are these different health facilities, as you may want to call them, these little clinics and hospitals where people get vaccinated. And people sometimes have to travel, hundreds of miles to actually come and get the vaccination. And if they find that there aren't enough vaccines when the people actually get there, they get frustrated, and then they go back to the community and say that, hey, do not bother going to that facility because they don't have vaccines. So that kind of spreads through the community, and these are called stockouts. Technically, these are called stockouts, and they don't get vaccinations. On the other hand, if you overstock the vaccines, in Africa, I come from India, and I can relate to this problem much more than when I'm living here in the US. Is that you have these frequent power outages, and and if you have ever held a vial of vaccine, you know how fragile that thing is, right? I mean, it's very, very fragile. So temperature fluctuations can actually deactivate that vaccine, and it'll be useless even if you do the vaccination. So too much of vaccines and too less of vaccines are bad. So we try to optimize how much vaccine should be stored at each health facility for the next 2 weeks. So this work has been funded very generously by the Bill and Melinda Gates Foundation. This work and some of the other work that is, kind of related to this. And we are very excited to kind of report that we have made some really good progress. So we are actually able to predict how much vaccine should you store, how much of rotaviral vaccine, how much of BCG, and how much of the polio vaccine should you actually store for the next 2 weeks. So predictive supply chain for vaccines. So this is the kind of work that we do, with the help of the Bill and Melinda Gates Foundation and some of our other nonprofit partners like PATH here in Seattle, and to developing countries like Africa. That kind of sums up the two different arms of MacroEyes.
Yeah, sounds like with Sybil, you could also repurpose that and sell it to airlines for no-shows, no-show passengers. They'd probably pay a lot for that.
Thank you for giving me that idea.
Yeah, but they don't do a very good job of it currently. Again, going back with healthcare, everybody's looking for data, right? You have some special challenges,
Yes.
correct? I mean, for example, I read an article about, I think it's Ereval, a startup that is associated with Institute for Systems Biology.
Yes.
And they gave access to their data. The startup Deadpool or shut down, and they were able to take their data from their population of users and develop a blood test for determining microbiome diversity without fecal samples. And the interesting punchline on that I read was, since the customers of Ereval were wealthy, fit, and in good health, it's actually not particularly representative of the overall population.
Yes.
So it's what are your challenges in getting data? I remember for your radiology study, for example, you struggled with that. I think Brian struggled with this.
I have, and I mean, we've even gone to the extent of generating synthetics very carefully in some of my practices, and it's, and also there's a lot of privacy concerns around some of the data that's out there in healthcare and life sciences. Are you running into any of those issues, Rob?
Yes. So, I mean, that is everyone's problems. So we are no exception. So as you can see, most of the models that people use currently to do things like, predicting how much of vaccines would be needed are based on population census data, which you might, imagine that is so outdated that is essentially pointless. It's data that, is like 6 or 10 years old data. So we need on the ground data, and we do talk to partners, who actually get the data for us. And it's very, very challenging. And we make sure that any data that is being shared with us is de-identified at source. And, there are ways of doing that, and then stored in Amazon or, Microsoft, all of which are HIPAA compliant. And we take data privacy very, very seriously. But for some of the vaccine-related work, we don't actually need, specific, patient-level data. So the patient is de-identified even from the very start. So we just know that someone has been vaccinated on this and this date with these vaccines. We have no idea who that person is. But with some of the civil data, uh, definitely we take great care to make sure that the data is protected in every way that is possible.
Perfect.
So
So we're getting close to our 26.1 mark, which is the average commute time, and that's the name of our podcast. That's what we're trying to keep this down to, so that people can get in on with their life after listening to a brilliant podcast and learning a little bit about you, Ram. Is there anything else you would like our listeners, our 500,000 listeners, to know about you, or any closing remarks you'd like to add to this icing on the cake?
well, the icing on the cake is just this: AI is here to stay. And as with anything that is powerful, there are good and bad things to it. Right now, we should be worried about what are the best ways to kind of encourage this and to make sure that we include everyone. So diversity and inclusion is as big a problem in AI as it is anywhere else in the world. This has to do with how we see things and how the data is collected. So if we kind of are aware of this, yeah, then I'm sure that AI has a very bright future in almost any application area that you can think of. Thanks so much for listening to me. Those are my closing words.
That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.